Tutorial sheet 2, problem number 1. So if you have tried, that's okay. If you have not tried, so let's see how we can solve this. So we are given a random sample of 12 sharing pins is taken in a study of Rockwell's hardness of the head on the pin. The measurements on the Rockwell hardness were made for each of the 12 pins, and there's an average which was calculated from the measurement, and there is also a sample standard deviation of 1.5. Assuming that the measurements to be normally distributed, we have to construct a 90% confidence interval for the mean Rockwell hardness. So how will you solve this problem? So what do we need and what's given here? We are given that there are 12 number of pins there, and there is some average is there, the measurements from these 12 pins, and there's average calculated that we denote with here with the x bar, and the value is 48.5. There is also given as a sample standard deviation that we denote with s, and the value is 1.5. Here you have to be very careful whether it's variance or standard deviation which is given. Sometimes they mention in the question the variance and we consider it the standard deviation, then we get confused what the actual measurement is. So the sample variance will be s square. The assumption here is that the measurements, the distribution here is the normal distribution, and we have to construct the 90% confidence interval for the mean. Let's mu be our mean Rockwell hardness. That is the quantity we are interested in. We have to estimate a 90% confidence interval. So this is what question is saying. So the question now is, how will we construct this confidence interval? Any idea for this?
So here alpha is 0.1.
Alpha, okay, so alpha is 0.1.
Yeah.
Okay, then that's correct, that alpha is 0.1. But the question is, how will you solve this? So the interval estimation problem depends on the distribution which you will be using to estimate a particular quantity. Now you will be using some quantity called a pivot element or pivot. So do you know anything about pivot? Which pivot we will be using here? So how do you decide which pivot to use? Different problems will be having different pivots. So how do you decide which pivot to use?
Sir, here we'll use T1 because your sigma square is unknown. We have sample mean S. So we'll use T equal to x bar minus mu divided by S underscore divided by root n.
Correct. That's what I was saying. So asking, like, so you have to check whether variance or population variance or sample variance, mean or whatever the quantities, whether they are given or not. So in this case, we will be using the pivot element as x bar minus mu divided s by root n. So what distribution this will be following? This is the pivot we will be using. This will be following
T distribution.
T distribution, and how many degrees of freedom?
N minus 1.
N-1, correct. So this is how you identify which pivot to use. There are other pivots. If the way the variance or standard deviation was given, then you would have used sigma by root n. And which distribution this pivot will be following?
Either normal or chi-square.
Yeah, it's normal, standard normal. So assuming that your xi's are normally distributed, this comes from the central limit theorem, and these are things are constructed further, and you will also be using that now some other quantities which you will be using in other questions. N-1 s square divided by sigma square, which we can write as summation I varies from 1 to n xi minus x bar over sigma square. So what will be the distribution for this pivot? This will be chi-square with n-1 degrees of freedom. So in this case, you are just adding standard normals n-1 If this was mu here, then this would have been chi-square n, chi-square n. Now instead of the population mean, we are using sample mean. Then this 1 degrees of freedom is lost because this mean can be expressed in terms of the data points. So the 1 degree of freedom is lost. So this is what you have to remember. So before proceeding to any question, you have to decide which pivot to use for that question. So that you have to take care. So in this question, we will be using this t distribution, right? So let's use our t distribution here, and let's see what measurements we can get. So now what is the shape of the t distribution? It is a symmetrical distribution, right? It's like normal distribution. So if I draw the t distribution, it's like this kind of distribution is there. So if there is some point here which I call as t alpha by 2 minus alpha, this point will be t alpha by 2, and this area will be alpha by 2, this area will be alpha by 2. What will be this area, the in between area? This will be 1 minus alpha. So now what the problem says, we have to construct 90% confidence interval for this. We already decided which pivot we have to use. So based on that, the distribution of that pivot is known. Pivot is something whose distribution is known, and it's free from arbitrary parameters. So the problem in which I have to construct the 95% confidence interval is, it will be something like this: sigma s by root n less than t alpha by 2. So this is the probability. This is 1 minus alpha, which means I'm saying between these 2 points, 90% of the area is between these 2 points, and this is how the probability is defined. And here we have to use the t table, and s is also already given, n is already given. We have to construct the confidence interval. So since you are calculating the probability values, if you go to the t table, then you have here alpha, you already told me that alpha is what is your alpha? Alpha is 0.1, right?
1.
Now alpha by 2 will be 0.05. Now with this, you have to look into the t table, and you have to find t alpha by 2, which is t 0.05. But there is also something associated with this, that is the degrees of freedom. So what is the degrees of freedom for this case? As I state here, it's n minus 1. So n is 12. Yeah, n minus 1, it's 11. So if you have used t table before, you should be able to tell me the value t of 0.5 with 11 degrees of freedom. Have you used this t table before? Or
Yes,
do
sir,
you know
but
how? Yeah, it will be given to you in questions, or in exam session. These things will be provided to you, but you should know how to look into the table. That I'm assuming that you know. So do you guys know how to look into the table, or I have to elaborate that part as well?
So kindly elaborate. That will be better for us.
Okay, so
Sir,
here
please
yeah, so here we came to the conclusion that our t, in the t table, we have to look to since our t will be having alpha and some degrees of freedom. Here alpha is our 0.05, which is alpha by 2 actually, the point we are looking for, and n, which was 12, but here if the degrees of freedom gets reduced to it's n minus 1, which is 11. So in the t table, we will be looking this value. Let me show you the t table. If you go for the t table, I have to change the window. T table. So is okay, in the last quiz only normal table was given, right? Then we have to look on online table. T table value. So you have to be very careful while looking at the just I'm I will show you the t table. Yeah, share window. This I have searched this online t table. So what this table is showing, they on one first column is it visible what I'm showing?
Yes, it is visible.
So what is given in the t table? There are degrees of freedom. The first column is saying the degrees of freedom and the level of significance alpha, which is these are two things we are interested. These are the two coordinates actually which guides you to the particular value. So in this case, our degrees of freedom is 11. That is 11th row we are looking for, and our alpha is 0.05. T alpha by 2 is 0.05. So what is this value? This is 2.201, right? Or one. Let's look t alpha by 2. Let's see what this table is actually. The table depends on the diagram actually, so it should show us. So there is no diagram given here, but you should consider before, like in the normal table there it's given whether we are considering right hand side, right tail, or left tail, or in between. Similarly, you have to identify the degrees of freedom, and you have to look into the value which you are. Let's say our alpha before this is since it's a two-sided, here it's mentioned it's a two-sided two-tail test. We will not be looking for t alpha by 2. We will be looking for t alpha. So t alpha, significance level alpha, then the value will be divided accordingly because it's calculated in that way. So 11 degrees of freedom with 0.1. So what is this value? This value is 1.796, right? Here I'm not able to zoom it, but you should be able to identify it in the 11th row and the third column. So this is how you look into the T table. T table has degrees of freedom, and it has the level of significance associated with it. Similarly, if you are looking for chi-square or some other distribution, then you should know what we are looking for. So this value what was this value? 1.796. So 1.796. This is my t alpha by 2 with 11 degrees of freedom. So we use this value here and there because it's a symmetrical way. Now my probability of minus 1.796 less than x
Sir,
bar.
please share the screen. Your my folder screen is visible, not the whiteboard.
Wait. Okay, sorry. I shared something else. Now, now you should be able to see it, right?
Yes, sir.
1.796, 796. So this is my values which I got from the T table. Now, and we know that this value is 1 minus alpha. This is 0.9, this probability. Okay, these things are here. Now swipe these things. So x bar you already know, right? So what will be you get? You will get x bar minus 1.796. Oh, there is something here, s by root n. That's also here. So yeah. So what will be this inequality now then? Whole thing, the confidence interval will be changed into the formula. What will be the formula for that? X bar minus t alpha by 2 with n minus 1 degrees of freedom, and I am multiplying this part, this what was here in the division, because we have to calculate for the mu. Mu is our entity of interest. So s by root n, this thing you will calculate x bar plus t alpha by 2 with n minus 1 degrees of freedom, and it's multiplied with s by root n. S you already know, t alpha by 2 you have already found. Say root n is also given there. So if you calculate this value, if you calculate, sometimes we call that a margin of error. This value is t alpha by 2 times s over root n. This value here is 1.796. 796 into 1.5 over root of 12. If you evaluate this value, you get 0.778. So what is your then final answer? X bar is already known, 48. So 48.50 minus this quantity 0.778, then comma 48.50 plus 0.778. And the value final answer for this is 47.72 comma 49.28. So this is my final confidence interval. So what in the final statement, what you have to write? So 100 into, which means 90% confidence interval for mu, which is the mean rock hardness of whatever the quantity was, under pivot you have to mention x bar minus mu s by root n, which follows t of n minus 1 degrees of freedom t distribution is. So what is your distribution? So I think sir might have told you that this is very important to mention which pivot you have used, because it depends on the pivot. So if you do not mention the pivot, you may get the zero in the examination. Okay, is it clear how we calculated this confidence interval using this table, T table, and how you have to write? And you should also write what this value mu was, which I already stated what my mu is. Oh, I did not specify, but it is the mean Rockwell hardness. So this is your quantity which you were looking, and for which the confidence interval you were looking for. Is it clear? Any doubts in this question? Because in the other questions we will not go in detail, we will just do the calculations. Any doubts in this question?
Sir, only thing is that T table that we referenced, right? So you said it is two-sided. That's why we, instead of alpha by 2, we used alpha. So if it is has it given one-sided, we one look for alpha there, right?
Yeah, but the table was two-sided, right? The table was two-sided, so it was by default giving T alpha by 2, right?
Okay, so we have to be careful there, right? Like which.
Yeah, you have to be very careful which table you are looking for. Even in the, suppose sometimes in your practice session you might have used some different normal table, but in exam you may get some different table and you may get confused. So there you have to look either on the table there may be some diagram given like this, how which part you are actually using. Each table is using some, whether it's calculating the right tail probability or it's calculating the left tail probability, that is specified on the table at the top or at the bottom. So sometimes they calculate this area, or sometimes they calculate area till this, or sometimes they just calculate the area just for the right hand side, and then you may get confused. There is 0.55 missing, so they assume that this part is 0.5 and we are just calculating this part of area, add this to this, your final answer will be that. Or sometimes they just give you the right hand side of that tail probability because of the symmetry, then you have to think accordingly. Okay, and sometimes if you are like using some skewed distribution, chi-square or some other, then there is no sense of alpha by 2, alpha by minus alpha by 2. There is there we state that which part we are, left part, right part, that there it is visible, but in here in this it's not visible. Sometimes half T half, and there you have to be careful. Okay, shall we move to the next question?
Yes.
Okay, so the next question is saying that an electric scale is giving some reading equal to the true weight plus some random error. The electrical machine is or some meter is giving true readings, and there is some random noise associated with that. It's giving the weight, and with that there is some due to some fluctuations, some error gets added to that. Then if let's say if your weight was some, let's say W, then the machine which is giving you the weight in return, it's adding some noise to it, w plus some error. This error is coming from a normal distribution with the mean 0 and its standard deviation sigma is 0.1. So our variance will be 0.1 square. So if it was giving just a true weight, then this was not a random variable. Since there is some error associated with it, this comes from random distribution, then here then it becomes a random variable. So if we look at the expected value of w, this will be after the random noise gets added, it will be let's say this is w bar. After that, then the expected value will be w plus epsilon, and this will be w plus expected value of epsilon. Here the value gets, actually w is a constant weight if it was returning a constant weight, and this is 0. So this is how the distribution, from which distribution it's coming. Due to the noise which gets added into this process, now we have to determine what there are some certain observations here. The distribution of error is given. Due to this, the distribution of w is also known. So what will be the distribution of w if the distribution of error is normal 0 comma this sigma square? What will be the distribution of w bar, my new variable which gets added, for which the noise is added? So the weight was just a constant quantity, then we are adding some noise, then it becomes a random variable. This w bar becomes a random variable, and this w, and earlier the expected value for me epsilon was 0, now it gets w. Then if you calculate the variance will remain same as that of the error distribution. So what we have to do, we are given this error distribution for which 0 mean and sigma is given. There are some successive measurements, weight measurements given. These are given here. We have to determine 90% confidence interval for true weight. So let's say w was my true weight. What will be the 90% confidence interval of that w after the noise is added due to this measurement? So which pivot you will be using here?
Normal distribution, because sigma and mu both are known.
Yeah. Now due to this addition, we also know the standard deviation or the variance of w. What will be the variance of w bar? It will be variance of w plus epsilon, right? So can I say that this is variance of w plus variance of epsilon? Or what will be the variance for w? Because the constant quantity, this will be 0, and this will be variance for this, that is already given 0.1 square. You have to be careful if you are distributing the variance over the sum. If they are not, either this is a constant quantity or these two things are independent, then you can distribute. Otherwise, there will be a covariance factor associated with this. So variance is not linear the way this expectation is. So variance for w is also given. That's also variance for w bar is also 0.1 square. So my sigma square is actually the same which was for this error distribution. Now x bar minus mu, I have to construct the confidence interval for mean true weight, which I am saying as, instead of here w bar, wait, this was just kind of this. Let's denote this by mu, because we know this is the actual true weight, and we know the distribution for this. What is the distribution? This is normal 0 comma 1. So I'm using, I should have used w here, but because we know this from the central limit theorem that it is in this format, the sample mean minus the true population mean, and if we scale with the standard deviation over root n, then this forms a normal distribution. So this is the pivot we have already identified. Now there are measurements given, you have to find the mean of these measurements. So if you sum these values, the mean which I already have calculated, which is 3.1 let me write here 3.150. This calculation I already made. So this is my mean x bar, and you are already given sigma or sigma square. This is 0.1. You have to do the sigma by root n here, and n is 5. 5 observations are given, then this value is calculated. You divide that here, but what is the actual, what is the format in which you will write? So how will you write this, that the confidence interval? So this is your now the z distribution in a symmetrical way, right? So if this is 1 minus alpha is in between, this is alpha by 2, this is alpha by 2, this is z alpha by 2, this is z alpha by 2, here is negative sign. Now what I'm saying, that we have to say that with probability z minus z alpha by 2 less or equal to my original z, this is the z variable, this is less or equal to minus z, sorry, this is z alpha by 2. This probability should be equal to 1 minus alpha, which is 90%. So alpha here is, what is the value of alpha? Alpha is 0.1. So alpha by 2 will be 0.05. So this is 90%, 0.09. So now you know the alpha, then you can, if you know the alpha, then you can find the z alpha by 2 from the normal table. Now you know how to do it. Earlier I showed for the t table, but for normal table, you should know it. Do you know this? How to calculate for the normal this z table? This you have already done in the quiz 1, right? I think that you should be able to identify the value. I think this is clear, right? How you can find the value of z alpha from the normal table. If I give you the normal table, you should be able to tell me the value, which is z alpha by 2, right? That part is clear now. Is it clear how you will find that z alpha by 2? So this is minus z alpha by 2 less or equal to x bar minus mu over sigma by root n. And this is also less or equal to z alpha by 2. If we simplify this and find the, with alpha and alpha by 2, using that you calculate this z quantity. This quantity you calculate, this quantity you already know, sigma by root n you already know. So your confidence interval becomes, the final shape it takes, x bar minus z alpha by 2 times sigma by root n, comma x bar plus z alpha by 2 into sigma by root n. This is your required confidence interval. Since alpha this is the 90% confidence interval we are looking for, because this 1 minus alpha is 0.9. So where all values are here given. X bar is, we have calculated here, x bar is here, sigma by root n is also here, we have sigma is here, root n is there. What is missing here? Z alpha by 2 is something you have to look from the table. If you know this value, then your interval is done. So I'm assuming that you know how to calculate, how to get it from the normal table. Now in the normal table, you will be having different probability values in between, and there you will be calculating the value of z based on which table it is. So do you know, or shall I show this part also, how you look into the z table?
So if this table also is a two-tailed table, then we would take the alpha value as 0.1. Similar to the t table.
Actually the it depends which table is given. Let's see. Let's see if we
you can
look.
show the table. I think that would be better.
Okay, let me show you the table. So this was the table, I think that this was given in your quiz, right? So what is this table? Is it two-sided, one-sided? That we have to see. See, if you some table, for some of the tables, it's the graph is given on the top. But here in the bottom, we are given that we are calculating here probability z greater than z alpha is alpha. So this is right sided. So this is if this is your normal distribution, and it's saying that this area is alpha, this is z alpha. So symmetrically you can look here for the other part, but this table is giving you this value, this probability. Now when we will be looking into this table, instead of alpha we will be looking at alpha by 2, right? So this table is
Yes.
giving you alpha, then but our point is having alpha by 2 here, alpha by 2 here, alpha that. So that's what. So what will be the value coming out from this table? So our z is we have to calculate z 0.05. So the value you have to look is where is 0.05 in between. What is 0.05?
First row.
Yeah.
So Z 0.05 is alpha by 2, right? But we have to look for alpha.
Yeah.
0.480.
See what I'm saying, that this table is giving you this z alpha, but we need this alpha by 2. We need alpha by 2. So we are, instead of alpha, we are considering alpha by 2. Using this table, we will be calculating alpha by 2. The way it's giving you alpha.
1.64.
1.64. Okay, so that's the value you receive from this 1.64.
So we can take 1.64 and 1.65 because the value is near 0.505 and 495.
So you can
both of them
this
would be
1
correct?
point. Yeah, those values are accepted. We may specify till what decimal places you can take. So this is the lowest, like this value is, I think, closest to 0.05, right? Among these values.
Both are same because
So
0.0495 it is there, right? 0.05. So it is same.
yeah, so
Plus and minus.
let's say you are just looking for 2 decimal places, then this value is more closer to. If you are looking for just 2 decimal places, if you are looking for beyond 2 decimal, then this is also accepted. But mostly we will be looking for just 2 decimal places. 0.05 is here, so we will take this value. So this is how you look into the, and your normal table may be different. That there you have to take care. So let's come back to our problem. So my final answer for this will be, so we were getting z alpha as 1 point, what was that value? 1.60,
1.64.
64. Yeah, that value you can put here, and other values are already given. Someone is joining now. Okay. That value, those values, if you put here, so let me write the final answer. So you will get 3.07 after this addition and subtraction, 672, 3.2237. Okay, this is your 90% confidence interval. Under the pivot, you have to specify 90% confidence interval for your mean under pivot. Pivot was the normal distribution, which was having normal distribution, sigma by root n. Okay, this was my pivot. So now in the part 2, it is saying that just now instead of 90%, now calculate the 99. So what will change here in the next part? Instead of 0.09, you will be having 0.99. Now here on you will just add, now your alpha will change here, and the process will remain same. Then you should that this part I am leaving as an exercise. Only alpha is changing there. Procedure is same. So okay, the second part is as an exercise. You try that. Just alpha is changing there. Then you will get some experience how to look into the table. Now the question 4 is there are a sample of 20 cigarettes is tested. The content of nicotine and the average value was So just from the question, read which parameters are given. N is given, which means the number of samples are given and their average value is there. We have to compute 99% two-sided confidence interval for the mean nicotine content of the cigarette of some particular type. If it's known that the standard deviation is given, again, which pivot you will be using? You will be using the normal part, right? Same which we used in the above case. X bar minus mu sigma by root n. This is the pivot which you will be using. Now what is given? N is given, which is 20. X bar is given, average value. Instead of a data, the value is directly given, which is 1.2 milligrams. Part A is saying that if sigma is given here, sigma is 0.2 milligrams, then what is we have to construct the 99% confidence interval for this quantity. So how will you do that? Again, we will be doing probability z alpha by 2 minus z alpha by 2 less than z alpha by 2. That should be 99%, which means 0.99. Here, this is equal to 1 minus alpha. Then alpha is, what is alpha? Alpha here in this case is 0.01.
0.01.
Now, yeah, 0.01. Then alpha by 2 will be 0.05.
0.025.
Right?
0.05.
Yeah. So you do this calculation. So probability that minus z alpha by 2 less than x bar minus mu over sigma by root n less than z alpha over 2, and this is 0.99. Now again, you look into a normal table, you calculate this z alpha by 2. So instead of going back again, I will just write so you will get probability that x bar minus z alpha by 2 times sigma by root n less than mu less than x bar plus z alpha by 2 times sigma by root n. So all the parameters are given. Just you have to look into the normal table again. Now z alpha by 2, which is 0.05, which I have already, sorry, z 0.05, 0.005, which I have already calculated. This is 2.576, and sigma by root n, which is 0. What is sigma? Sigma is, yeah, 0.2 root of 20. This value is coming out to be 0.0447. So this is your sigma by root n. Z alpha by 2 is there, and x bar you already know, which is also given in the question. So this is your confidence interval, and your final answer will be, let me write the final answer, 1.0848, 1.3152. Okay, so this is your 99% confidence interval. Let's write in a clear way, 99% confidence interval for the mean nicotine content. I think they are asking mean nicotine content. That this you should write in the exam. Mean nicotine content. What is actually the problem is saying? For me, under the pivot of x bar minus mu over sigma by root n, which follows z distribution, z normal. This you should write in the and the value is this. This is how you write in exams. Okay, so is it clear till this part? Then other questions will be, there is also next part for this, which is about a bound. We have to look. I will quickly go for this part, and some the other questions will be done by Anil. So the other part is saying that we have to compute a value for which we can assert that 99% confidence that C is larger than the mean nicotine content. So C is larger than mean nicotine content. You have to find this value of C kind of bound for your, so that the 99% confidence you are saying that your mean nicotine content is greater than this C. So what the part B is saying that it's kind of one-sided confidence interval. So we have to find the probability. Let's say mean mu is our nicotine content is greater or equal to C. This we have to find, and we are sure that it's 1 minus alpha, which is 99%. You are giving the 99%. So what will be alpha here? Alpha is 0.01. So how to proceed for this? So what I will be doing there, that I will just do the reverse process here. This will be probability that x bar, the mean which is already given, x bar minus C. I will be doing the division also, x bar minus mu over sigma by root n, because sigma is already known. That will be x bar minus C over sigma by root n, and this probability is 1 minus alpha, which is 0.99, right? Then our goal here is to find the value of C. So if I look closely, that this part is becoming my z, and I'm assuming that this is z alpha, and this value is 1 minus alpha. So what we are doing here, we have to find a bound z alpha such that this part is alpha and this part is 1 minus alpha. So if you look into the standard normal table, find this value. What is your alpha here? Here you will be using directly the alpha 0.01, because we are calculating the z alpha. So if we look z alpha, which is z alpha is 0.01, the value for this is 2.3326. Okay, now you got your z alpha, but you have to equate this z alpha. Z alpha is equal to x bar minus C over sigma by root n, right? This is what we assumed as z alpha. This part is z alpha. This was z. This is z alpha. So z alpha you got from the normal table. Now with this, you x bar you already know, and C, the bond which we are looking for, you have to get from this equation, and that you try yourself, which means you find the value of C. All you have to do is the substitution of x bar, sigma, and root n, and you should be able to get the value of C. So C will be, what will be C? X bar minus z alpha times sigma by root n. This will be your C, value of C. The values here are on the right side are all known, and you put that value and get your value. Okay. I hope it's clear till now. Any
Yes.
doubts till now?
Yes.
Okay.